So, this is going to be a video on homeostasis and feedback loops and basic stuff that a student in anatomy and physiology will see. And I'm going to also use this video to kind of project where we're going. So we're still new into the course at this point. So, brought to you by Curious Moranland, where science literacy will make America great. So, first I'm just going to turn on my writing tool. So this is a textbook reference. This is the section 1.6. We'll talk about homeostasis, negative feedback. I'll mention positive as well. However, most of the organ systems and living systems, they use negative feedback. And you're going to hear us talk about homeostasis and homeostatic imbalance or homeostatic regulation. So this is a generic input-output system, but so if this is a living system, it's not in and then out. Really, this is what's happening. You've got to regulate what's going in. A typical case of a paramecium, they have a structure called a contractile vacuole. They're in a hypotonic solution, fresh water. Water's going to go in, water's going to go in. If they don't take that and do something with it, they'll explode. So even on a simple single-cell organism, homeostatic balance and control are essential for life to be sustained in your normal everyday environment. And that's really what feedback is about. So I'm not going to spend a lot of time describing it. If you're one of my students, I would say pause the video at this second, just take a look at this. What I'm going to emphasize is this right here. These are some buzzwords that I got from Bozeman Science, and here's some examples. So think about it. Negative feedback, you're going to basically trigger something to respond to that stimulus so the intensity doesn't cause adverse problems. Positive feedback, it's going to keep pushing that stimulus. It's going to keep pushing it. So these are the two buzzwords that go with it. Stabilize or stabilization, and to amplify or amplification. Here are some examples, and I'm going to talk about these two in this example. I'll show blood clotting, and these are two I just usually talk to the students in class. So, if you look at the top, homeostasis, the ability to maintain a stable environment despite this, whether it's external, that's you're shivering because it's cold outside, or internal, something that's going on inside your body. So what I just drew here is, it's not a straight line. You're going to have ebbs where you go up and then you go down, up and down, and homeostatic control prevents something from going way out of whack, going up too high or too low. We use the term hyper and hypo. I'll use that in this video as well. So take a look. So a positive feedback, what happens is, so here's this set point. Positive feedback doesn't maintain homeostasis. It runs its course. If we go back to this, unfortunately, if you're in a situation where you go high and you don't come back down, that's a homeostatic imbalance that could cause disease. The same thing as here is if you go low and you don't come back down, that's going to cause a problem. So there are instances when you want positive feedback, but in most living systems, a majority of them, the control is going to be the negative feedback. So we'll elaborate. So here's what negative feedback does. If start here, and so let's just use this example. All right, you got receptors in the blood vessels. They're going to do something. What do? The control center. I need to stop and define those terms in a second. So instead of going too high, the heart rate is going to decrease, and that's going to bring it back down, bring it back down. Here's that, kind of view this, and this is maybe that high point, and that's the low. It's a bad W, but it's the low. So in one time you might decrease the heart rate to bring it back down. Here you might, maybe you're too low, you might increase the heart rate. So let's delve into this and get a little bit deeper, and we'll finish with some examples. All right? So that's, again, positive feedback. Here's one example where you want positive feedback, blood clotting. So just pause the video and kind of read through that. I want to focus on some other terms. So again, you can pause the video here. So maintenance, this is pretty much textbook stuff. But notice this, homeostatic imbalance. A lot of times that imbalance is what causes diseases. All right, too much blood sugar. Instead of saying high, I would say hyperglycemic. All right, too low blood sugar, I would say hypoglycemic. Hyperglycemic is someone who is a diabetic, or could result in that. Okay, I'm going to skip to this. This is something that we'll be doing in class where we have a discussion about it. But for the sake of the video, I'm just going to jump to this part. So what I want to do is now let's start infusing in these terms. I don't want to do too long of a video, but one of the things I want you to recognize: a receptor and an effector. All right, a receptor and an effector. Those are organs. I don't have it written here, but these are organs versus stimulus and response. Those are actions. And then we want to bring in the control center. So this is going to get more complex and end up with an actual living system. We'll look at the thermal regulation in a moment. So, all right, you're cold, homeostasis, normal room temperature. The stimulus is the temperature goes high. The receptor here is going to, in this case using the thermometer, the receptor is going to communicate to the control center, which is going to basically turn the air conditioning on. So because you're like really hot, so you want to cool off. So I didn't really say that well, but let's move on to this. All right, here's something from our nervous system, and really, if you want to do well in this course, take this and overlay it over all the systems. You're going to have input, and then you can talk about what's going on here. Integration, output. Right, output, the effector. These are, again, organs. This could be muscles. This could be glands. This could be blood vessels. This could be internal organs that are going to have some action, some response. View the effector as the one that does the response. And then your nervous system, and then the integration system, which we could spend a long time talking about that. So now, just pause for the video. In class, what we would do is we'd try and identify all the things that are going on. Like, here's a stimulus, and these are two sides of a similar situation. One is increased body temperature. One is decreased body temperature. What does your body do? So I want to throw this into a generic category first, and this is where you would, again, the effector here, the receptor, again, those are going to be organs. And then this is the stimulus. All right. Now, what I like about this is it's showing you homeostasis. And I'm going to look right. So when you go above that set point, homeostasis is in imbalance. Homeostasis is regulated and because of a negative feedback mechanism. And so take a second. This is something we do in class. We try to troubleshoot and say what's going on. But let's actually look at an example. So first, and before I wind down this video, we're going to do thermal regulation. And if you see this, the body temperature drops, the body temperature is high. So this is hyper, this is hypo, and let's see what is happening here. Vasoconstrict, as we get into the circulatory system, we'll talk about that. So, let's see. There's that generic one again. Let's move down to here. So, we got some stuff going on here. So here's the stimulus. Here's high. Here's low, and you know you can say hyper or hypo. So follow along. You have stimulus. This is going to cause something. The set point, the regulator, is your hypothalamus. That's an organ. It's in your brain. And that's going to activate two things. It's going to cause this. The skin is going to, the vessels are going to dilate. All right? Capillaries are going to be flush with warm blood to heat the surface of the skin. Now, well, why would you want that to happen? All right? You're pulling the warm blood towards the skin. This is why you turn red when you're hot. Well, but you're also cooling the internal organs. You're pulling that warm blood out to the surface. And that's also going to cause the sweat glands to be activated, and you're going to perspire. You're going to get rid of that heat. And the result, here's the response. Stimulus over here is your response. I'm just going to write an R for response here. That's going to cool your temperature. Now you're back to your balance. Okay. The other side of this would be you're cold. Okay. So the decreased body temperature, as you see here, so there's, say you're out in the winter or you're falling in a lake and you're cold, right? So the blood is cooler in the hypothalamic point. That's the set point. That's where your homeostatic imbalance gets pushed down now. If you follow the mouse, pushed down. Okay, so now it's like, hey, we need to get warmed up. So now the skin from the blood vessels, they're going to constrict. They're going to constrict. That means they're going to get smaller, and then you're going to take the blood from the skin and you're going to shoot that to the deep tissue to warm them up, to warm your core. And while that's going on, did you notice up here at the top that you started sweating? So remember, the effectors, and that's what this is, all right? The receptors are here and the control center. They're effectors. They're the response. Okay, so your response, I'm going to go R over here for response, and you notice it was blood vessels here, but now the muscles, they're going to start pushing and they're going to start contracting. In this, you're going to be shivering, and that's going to create heat, and that's going to also warm the core. But the blood that goes from the skin to the internal organs is going to warm them up as well. All right, so this is what's called thermal regulation. It's a homeostatic regulatory system, so to speak, and it's actually an example of a negative feedback. Now, I'm going to pause the video. I'm not going to talk as much about this, but you could still say the same thing. Here's your stimulus. You got your hyper, and I'm not doing a good job of typing with my mouse here. Hyper. Okay, over here, your hypo. Okay, so there's a series of events that are going on here. I'm running low on time, so I'm going to just say pause the video. In class, we would actually go over this in a little more detail. And watch the next slide. This is a picture with descriptions. This is just written description. A successful anatomy student ought to be able to say, look at this written text and come up with a drawing or a sketch. A successful anatomy student also should be able to look at these pictures and with all this stuff maybe have this blanked out and then write written descriptions of what's going on here, what's going on here. And that's really, say, look at this picture and draw simple declarative sentences like a free response or an essay. So, all right, thanks for watching.